anything to do with the notes we would have taken on circles?
What?
Because we
The
have,
project?
Yeah. Okay, because we have notes very similar to
Near there, easy. All right, cool. I'll get started. Yeah, we don't need anything that we're doing at this point forward to do that, except for like the area of a circle, stuff that you already know.
So it was like,
No. I like that. Good. Thank you. Thank you. So I want to start off. I try not to make this confusing. What we're going to be working with is this process called completing the square, and some of you guys have already seen it. It's crazy. I kind of messed up second hour because I showed them how completing the square has been used to create the quadratic equation, but I think that was just blew everybody out of the water because it's so abstract. If anybody wants to see, maybe we'll do it at the end, how to construct the quadratic by completing the square, and it might make a little bit more sense. But here's this idea real quick, okay? And I'm going to start it like this. Let's take a perfect square, something like x plus 5. Okay, that's a square, right? It's some number squared, some number times itself. In this case, it's whatever x plus 5 is, that quantity, x plus 5. Are there questions on what I've just written up there? Now, everyone understands that if I want to expand this, I would have to do my little FOIL thing, right? And I'm not going to try not to skip any steps here. So this is technically going to be x plus 5 times x plus 5. Why? Why? Well, it's this number times itself, isn't it? Because it's squared. So it's x plus 5 times x plus 5. Now, I can still keep going and use my binomial expansion process here. So x times x gives me x squared. Then I've got 5x. And then I'm going to have 5x plus 25. So there's some very important things I want you to notice here. Where did x squared come from?
First to first.
The first one squared, right? Where did 25 come from?
5 squared.
The 5 squared. Notice how this is actually 10x. Where does 10x come from? Multiplying the two values and then doubling them. If I took these two values, x and 5, I multiply them. That gives me 5x, right? And then I double it. And why do I double it? Because it happens twice. Questions on that? No matter what type of value I square, the same process happens every single time. So if I took a value of, may I clear this? Anybody still need any of this? Okay, cool. So if I took something like x minus, not 2, I don't like 2. Let's go with x minus 3 squared. Then here's the process would be the first one squared, negative 3 times x, which is negative 3x, and I double it. That becomes negative 6x. Does anyone understand that? Because remember that middle piece would happen twice? Then I can take negative 3 and square it, which gives me the last one. And there it is. Any questions from anyone? Okay, the middle part is simply this times this twice. So negative 3 times x is negative 3x. And if I double it, I get negative 6x. Now I can show you the long way, which would be x minus 3, x minus 3. X times x is x squared. Here's a negative 3x. There's a negative 3x. And there's my positive 9. And there's the middle part one more time. 3x happens twice. You see that? Okay, anyone have questions on that? Okay. I want you to notice that if I clean this up, this is x squared plus 10x plus 25. This factors into a perfect square. This also factors into a perfect square. Do I have a perfect square here? I don't. Can I factor that into a perfect square?
No.
Why? Well, 0 times 0 is still 0. Okay, examine the structures. Here,
It's missing one.
here, it's missing something, isn't it? What's it missing?
It's missing the plus.
It's missing the constant, the number by itself. So what we're going to do is go through this process that's called completing the square. Because I want to see it, I want to convert it to something like that. I like that. Okay, especially like if I'm working with a circle. Because I know that what happened to the x? It got moved, right? But if I look at this, can I see what happened to x in that scenario? No. So I like the top one, don't I? So what we're going to do is we're going to go from something that looks like this bad boy to something that looks like that. Much better for us. Easier for us to interpret. Okay? And it's a very simple process. Okay? It looks tedious sometimes, but it's really just super simple. Let's think about this backwards. First, it's going to be something that looks like that, right? And that first number is, or the first entry is always x. It's the square root of this. We're doing the opposite. Where did this 10x come from? It came from those two outside insides, right? And we doubled it. So how do we get this number back? Divided by 2. Half it. Good job. So plus 5. So we're going to half that. And then here's where something interesting happens. The fact that I did this adds something to the equation that wasn't there. The constant. And what is the constant in this case?
25.
It's 25. So this adds 25 to the left side of the equation. So all three of these factor into this. Can I do that? Can I just drop a number in there and be like, we're good? No. What do I need to do?
Add it to the other side.
If I want to bounce this back out, I need to do it to the other side. So that will become 0 plus 25, 25. And there it is, friends. I just completed the square. Okay.
It's going to be the same process for every single question.
Every single one. Well, not every single one. Sometimes there might be something in front of x squared. And you'll get to see that, okay? Yeah, I'll do one more, okay? Oh, it's much more than that. Are we good here? Okay. So let's take a look at maybe this binomial here, or this expression, x squared. Let's go plus 14x. What's my binomial entry going to look like?
X plus 7.
Beautiful. X plus 7. And what is the extra portion that's going to get added? 49. Good. Awesome. Yeah. So easy. Me gusta. I love it a lot. We're good? Okay. I wish I could have done this with you last time we met, because we're going to do something like this. So, well, that's not what I wanted at all. Oh, that's not the one. Here it is. Cancel. Here we go. Alright, so let me take. So I want to show you what an equation of a circle actually looks like. That's what an equation of a circle looks like. We don't like that too much. We like the ones we were working with yesterday. That was so easy to see what happened to the center and what the radius is. Right? I'll wait for you guys to write this down because it's pretty sloppy. That's the equation of a circle, yeah. Interesting, huh? Oh, for sure. Are we good? May I continue?
Yeah.
All right, cool. So, do you guys want to watch me do this first, and then you guys can copy what you want? And then there can be questions as we go. All right, so I have this problem. I'm going to first rewrite it because I kind of like my variables to be on the left side. That's a personal choice. I don't know if it matters to you guys. So first I'm going to go y squared minus x squared plus 8y plus 6x equals 16. So you guys can see I just flip-flopped that, right? Good. Now, I don't want these x's actually to be negatives. I don't want x to be negative. So I'm going to divide everything by a -1. Let me take a shortcut. Is that cool with you guys? Divide everything by -1. Which, I mean, that's the shortcut, right? So this becomes y squared plus x squared minus 8y minus 6x equals -16. Everyone okay? All right, here's where the good stuff begins. I'm going to put my x's and y's together. I'm just going to group them. And I like my x's to go first. So I'm going to go x squared minus 6x plus y squared minus 8y is -16. And what I'm doing is just trying to keep it clean. Because, I mean, it's a big problem, right? So, are we good so far? No one's lost? Just real quick, a little thumbs up. No one's cool? Lost you? We're good? All right, awesome. Can I continue? Okay, I'm going to chunk this into pieces first. I'm going to worry about the x's alone. I'm going to complete the square there. So if I completed the square with the x's, that would be x minus 3 quantity squared, correct? But that adds a little something, doesn't it? What did I add? I added 9. So I'm using 9 here. I'm going to balance it out by adding 9 on this side. Everyone cool with that? Okay, we're doing okay? If I were to factor this out again, it would be x squared. -3 times -3 twice would give me -6. But then -3 squared would give me 9. And it wasn't there, was it? So I went ahead and added it over here just to keep balance. Cool? No, I just did 1. Now I got to do the y. I'm going to complete the square for y. What's this binomial look like? Quantity squared. What's that little extra something that was added here? 16. What? 16. So I'm going to go ahead and balance it out by adding 16 over here. Everyone cool with that? So now I just clean up the other side, which means this equals 9. Whoa, that wasn't bad at all. Now I know that I've got a circle centered at 3, 4 with a radius of 3.
Because you use the formula that
What if, say y squared was positive, but then x squared was negative? What would you do then?
You don't. That wouldn't be a circle at all.
Okay.
Okay? We'll ask that in a little bit. Let everybody catch up. What's the square root of 9? Remember, it was x squared plus y squared equals radius squared? You weren't here for that. I have to give you that formula, okay? So we'll do that in a little bit. Do it now.
Wait, can you scroll?
Okay.
Is that a 6x or a 6y?
Here?
No, yeah, well, I guess it's a success.
It's a success.
It's 6x.
Can you scroll down? Can you show like the whole page?
There's no down. Oh, you mean scroll up? No, I didn't. What now?
He just moved where everything was.
Why does it become a negative 6x?
Oh, no. I wrote y instead of it.
I missed the bus.
So which means we only have 13 problems. No, I'm not.
Okay. I just want to cover what we did last time very quickly, for the sake of those that weren't here. If you kind of think of this real quick, let's say we have some point out here, McKenna, out random in some random spot. We know that we can find its distance by kind of manipulating the situation. If we created a right triangle, calling this x, calling this y, then I know that to find the distance from to that point is simply a Pythagorean question, isn't it? So it would be distance x squared plus y squared equals the radius squared. Now, would this change if my point was over here somewhere instead of where it is now? It would still be x squared plus y squared, right? Well, what about any point that is on a circle? Would it change then? So this is actually the formula for a circle. And that's why when we wanted to find the radius in the other question, it's simply the square root of that number. Because to get that number, you have to take radius and square it. That was fast. Go, McKenna. How do you guys feel about that? That wasn't so bad, huh? You want to just like destroy your dreams, shatter your dreams right now?
No, please, no.
Oh, come on.
I don't like my dreams.
Let her finish copying down the problem.
Oh, you haven't been done with it?
She.
McKenna, are you done with this page? Here?
No, she was copying mine. She
Oh,
hadn't done it.
okay. You guys want to see another one?
Yeah.
One more time? You're good? If there's questions, please ask them, okay? Alicia? You guys are awfully quiet on this side. Ah, these are our kind.
Yeah, no.
Don't go changing.
Don't go chasing.
Okay. Thank you. Muchas gracias. I'm going to do a couple different things in one step, just to kind of minimize the amount of writing up there, but hopefully you'll know exactly what I did, okay? So, I'm going to go with x squared plus 2x plus, that's not a y, that's a 9. Okay? So what I did is to bring all the variables to the left side, leave the constants on the right side.
But
Go ahead. It's on the left side. Did I move it?
yeah, you put it.
The 2x is already on the left.
And then
Everything else would change. The 2x stayed on the same side.
Yeah. This is on the right side. I moved it to the left side so it becomes positive. That was already there, so it doesn't change signs.
You changed it. I changed it.
Okay.
Oh wait, you just
Yeah,
added
yeah,
everything.
yeah.
So the y's would become positive.
Yeah, so yeah, that's right. Yeah.
I was thinking you added
Okay. Like, you guys can make me kick this old school, huh? Old sad face.
No, I understood.
Okay, you don't need to do it step by step. We
No?
understand the process now.
Alright.
You just kind of have to explain yourself a little bit. Then.
Yeah.
Well, that's why I said I hope you guys would understand what I did. Anything I need to explain? Any part of it?
Wait.
Alright, cool.
How do you get
Okay, I see what you
the negative x squared to the positive?
It was on the right side of the equation, so I moved it to the left side. Have you guys ever heard of the... Oh, you guys didn't take algebra with me. Okay, I have a little trick that I've coined it, change side, change sign. And some of you guys have heard that before. Change side, change sign. I can pick up an entire term, and if it's on one side of the equation, I can change a side that it's on, as long as I change the sign that it has. Change side, change sign. No, I'm just kidding. Change side, change sign. Change side, change sign.
I feel like that's an inspirational quote.
So,
No, not ching chai, ching chai.
Delta side, delta sign.
Delta side. Sorry. It was from a movie, that's why.
Hooty hoo.
She's so dumb.
little alpha theta.
However you do that.
Oh, we got all kinds of numbers.
Yeah.
And my pinkies are crooked, so.
We might have to just start meeting ourselves. Get you guys involved.
The who?
Okay. Are we good here? May I continue?
Yeah.
Okay. Let's start with the x's. This will be x plus 1. The extra is a 1, so I'm going to add 1 over here as well. Yeah?
Yeah.
Plus y plus 4 quantity squared, because that's the square root of y and then half of 8. That adds 16. Therefore, this is going to be equal to 1. So I have a circle. McKenna, where's it centered at? The opposite of, well, actually, what makes this 0? Negative 1. What makes that 0? Negative 4. So it's negative 1 comma negative 4, and the radius is going to be 1. And is it because it's this one? Because it's the square root of that 1. And the square root of that 1 is 1. I love 1. It's so cool. It's so cool.
What is that? You might know curry.
Yeah. Huh? I can try. Now, I do want to answer this. You just asked, what if it turns out that even though I did move everything to one side, and maybe I've got like negative x squared, right? Well, if I divide everything by negative 1, what's going to happen to y squared? It's going to change sign, isn't it? So regardless, if they're opposite signs, one will always be the opposite of the other, even if I try to fix it. And this kind of should hopefully make sense to you. If what we're looking at here is a circle, and I want to show you a circle in its basic form. So it would be x squared plus y squared equals the radius squared, right? And it would look like, it would look like this. Okay? Everyone cool with that? Now, if you end up with x squared minus y squared equals, and technically I think we call that 1. Okay? It would still kind of be an r, but there's a little bit of more nuances to that. It would actually be this thing. If I took this circle and I cut it, and took this piece and I flipped it.
Oh, because y is negative and then x a b.
They're moving away from each other, which is called a hyperbola. So you would get hyperbola. Okay. And I forget which one goes first because there's two versions to that hyperbola. There's an x squared minus y squared, and there's a y squared minus x squared. And what's the difference? Well, one is up and down, while the other one would be a left to right.
You explained it last class, Margaret.
Yeah? Cool. So, yeah. But that's what happens when you have differences. It would be hyperbolas. Okay? You won't see that till second year algebra. Oh, this one looks difficult. It's got some radicals in there, right?
So we'll see it next year.
Well, I won't care until this year. Alright, good.
Someone said, can you do a more difficult one?
Caleb?
Kella? Actually, this is a really good example. And I want to tell you why. Check this out. 4x squared minus 8x radical 2 plus 4y squared minus 12y equals a negative 1. Someone double check my work.
I don't even know what you're
Yeah?
Okay, yeah.
Okay. I don't want these 4's there. That messes everything up. So I'm going to divide by 4. So divide by 4. Oh, you know what? Shortcut. Shortcut. So that gives me x squared minus 2x radical 2 plus y squared minus 3y is still equal to a negative 1/4. Okay? Now, let's go with the x's. X minus, what goes there? It would just be radical 2.
It just okay, so you don't divide the radical by 2?
Well, actually we did. Here, let me show it to you here in green. Because this is technically this is 2 times x times the square root of 2. So I'm going to rewrite this as 2 square root of 2 and then times x. Is that cool? Now if I divide it by 2, which is half of that, 2 over 2 makes 1. So I simply get the radical 2 piece.
Where the x go?
We don't include it because remember it goes this times this to get our x back.
Okay.
Think about this. If I did this times this and I doubled it, I would get that. I would get 2 x radical 2's.
Got it. Okay.
Yeah?
Yeah, okay.
Pretty sweet.
Can you explain that?
So, this is what I need to take half of, the coefficient of this. Well, radical 2 is a number. So I'm going to rewrite it as negative 2 square root of 2 times x. And what I want is half of this coefficient. So if I take negative 2 radical 2 and divide it by 2, what is 2 over 2? 1. So I have 1 or negative 1 radical 2. Do I need to express the 1 there? No, because I only have 1 radical 2. Now, remember if I want to go back, it's really this value times this value, right? And then I double it. So this would give me negative radical 2 times x. There is negative x radical 2 times. Okay. So that's a question. Yeah, what is new here?
Yeah, what's new?
Well, think about this. What is the square root of 2 squared? 2. So we've actually added 2 in this scenario. So we're going to add 2 to this side. And now we can focus on the y values. The y values will read plus. What's half of negative 3?
1.5. Or 2/2.
I ain't trying to be fancy here. I'm not being tested on fractions. So that's perfectly legit. There's nothing wrong with that.
We usually add it.
Mr. Munoz is trained to read that. What's up?
Wouldn't you be adding numbers or subtracting each other?
What's half of a negative 3? Negative 3 halves?
It's still the equation. Never mind. I automatically just went like x equals.
Okay. So what does that produce for me? An extra what? An extra You said it. Who said it? It's an extra 9/4. Oh, then you're wrong.
Okay.
And how did I get 9/4?
Multiply 3 halves.
What's 3 squared?
9.
What's 2 squared?
4.
Ayah. So to balance it out, 9/4 on the other side. Now that's kind of cool because 9 minus 1 gives me 8. 8 divided by 2, 8 divided by 4 is 2. It used to be 0. So 2 plus 2 gives me, so I've got a circle that's centered at positive square root of 2, comma, positive 3 halves, with a radius of 2. It's the square root of that value.
How is it?
Huh?
How is that?
It's not. But that's as worse. That's as bad as it gets. I really like it. Go for it. Awesome. I love questions.
We're to just factor out the 4 and then keep the constant. Is that how you get the y equals a times x times h thing, the equation?
Yeah,
Because instead of dividing them, you just factor it out.
you could.
Okay, just checking.
Now, I want to do a little side note because I know I've done it for all the other classes.
Hey.
Hay is for horses.
I say nay to that.
What's up?
It equals -1. I thought it was just positive.
Nope. It was positive on the left side. I moved it to the right side, therefore I have to change the sign. Thank you. And they've been sitting here forever, and I've been trying to return it to you, but you're either I'm distracted or I'm out. All right, cool. Are we good here? Big thumbs up. What's the matter, Bosh?
What?
Oh, okay. All right, cool. Sir? Can I move the slide now, Lorena?
In a minute.
Can you wait?
Are you recording this? Wait.
No, I'm not. The computer is.
Hey.
Ta-doom-doom. Sha.
We can't see what I'm doing.
That's negative 1/4 plus 9/4, so it wouldn't be. Wait, what?
9/4 minus 1/4 is
Never
8/4.
mind. Okay, I was reading that wrong.
Okay. All right.
No. You have like you're sticking out of the hole.
Silence, children. Take it down. Down, down, baby. This is a quadratic expression. It's a quadratic. Don't write this down. Just watch, because it's so fun to watch this. Watch me. Watch me. Oh. Watch me complete the square. Now I'm going to make this an equation just by adding equals 0. Okay? Because what I want to show you is something really cool and something that you probably didn't know where it came from, and now you will know. And that's just so much fun. Yes. So, and spoiler alert, if this is a quadratic expression, and we go through the complete the square process, we actually end up with what you guys have been calling the quadratic formula. Because what we're going to do is we're going to solve this for x. So watch this. I'm going to take ax squared plus bx and isolate it from c. So it becomes a negative c. I don't want a here because remember it's nice when I just go x, the square root of x squared. So I'm going to divide everything by a. So divide by a, divide by a, divided by a. And we're good still? This gives me x squared plus b over ax equals negative c over a. Here's where we complete our square. What's half of b over a? Half of B over A?
B over 2A.
It is B over 2A. That is correct. Okay? That produces something extra, doesn't it? It produces B squared over 4A squared, doesn't it? So that means I've got to make sure I add it to the... Wait a minute, who said sure? What's B squared? What's 2 squared? What's A squared? Yes? Okay, not sure. So that means I've got to balance it out and add it over here. So that's a B squared, 4A squared as well. I don't like having two fractions, so I'm going to combine them with a common denominator. My common denominator happens to be 4A squared. Now, did this denominator change from here to here? So my B squared doesn't change. That stays B squared. Did A change? I had to multiply it by 4A. Right, so times 4A. So I need to do it to the top as well. So that means I'm going to get minus 4AC.
Oh, it's happening.
It's happening.
It's happening.
Remember, the goal is to get x by itself.
I'm scared.
What's the opposite of squaring something?
Finding
Finding the square root. So we're going to square root both sides. That gives me x plus b over 2a is equal to,
square root B squared.
so you roll. I can't take the square. I can't take the square root of the numerator, so I'm going to leave it as is. B squared minus 4ac, but I can't take the square root of the denominator.
2A.
That's 2a. The square root of 4 is 2. The square root of a squared is just a. Now, since I took the square root of a square, I have to make sure I add plus minus. What did I just miss?
I don't even know.
I want x by itself.
No, like, continue.
Well, thank you for your permission. I'm going to move that over. It becomes negative b over 2a plus minus the square root of b squared minus 4 times a times c, all divided by 2a. Finally, I notice that I have two denominators that are the same, so I can go ahead and join those as well. And that gives me negative b, the square root of... Yeah!
Holy. Wait, can you scroll up?
Wait, question.
Math!
Let's take a picture of this.
This is a historic moment.
show this to all time.
He showed us this last year.
No, he didn't show us how to find it.
Yes, he did.
Yes, he did. He did this exact same thing.
Well, that just shows how I
Yeah, like Caleb paid attention during fourth hour.
I didn't have a all that straightforward knowledge.
Yeah, he wasn't in our class.
What hour did you have?
Was he in our class?
No, I had the first hour.
First hour.
Yes.
Where'd that come from?
We took the square root of a square.
Oh, sorry.
You know why you do square root of a
Is
square?
that a story moment?
Oops. No, come back. If I asked you this, what is x?
Oh, it can be 3 or negative 3. Okay.
So you have to make sure you include both versions of that, therefore plus minus.
Wait, why is
Okay, go ahead.
Wouldn't this B squared over 4A squared be negative?
Say that one more time.
I said, wouldn't the B squared over 4A?
No, I didn't change the side it was on. That was the extra that was created by doing this. So remember how when we had here, like when I had, where'd it go? Like here when I had an extra 2, I added it over here as well. That's what happened with that. With that B squared, 4A squared. Okay? Thank you, good question. Anybody else? That was so fun. I think it's less cool when you know what's gonna end up at. It's like you're just waiting for it, right? Like wait for it.
No, it's cool. You're like, oh, there's that's that thing. Oh, there's that thing.
Ow.
So here's something that's kind of cool. Later on when you guys start working, actually you guys should have done this. Hopefully you did this in algebra. You'll see that they give you an expression like this, and you can graph it and find all its important values using the quadratic expression. Or you can just simply take that, complete the square, and put it into what's called a, the intercept, vertex form, into vertex form. Or you can do it that way, so a couple of different things. Anybody want to see that? No? How about I just do my homework? Yeah. Work's already on Canvas. There are 14 problems.
11 problems now. You did 3 of them.
No, change the numbers.
That was mean.
I know, huh?
I thought number 1 wasn't it 16? The equals?
Do you know how
I thought that was
angry that
the
makes
first
me
one,
now?
or whatever.
Can you put the thing on the board?
Don't go changing.
No, it is not.
Oh, hold on, let me turn this off already.